All right, this is Honors Algebra 2 Pre-Calculus. We're doing 7.3 in Algebra 2. This is our third video. We're doing long division of polynomials. So the first thing we're going to do is do a review of old school long division, like the kind of stuff you did in 4th grade, kind of old school. All right, so usually you were handed a division problem that looked like this, something like 4,234 divided by 12. Or you might see it with the other kind of division where the division bar is underneath. So either way, the first thing you do is you rewrite this with that like division box, right? So we rewrite with the division box, check. Okay. The divisor, 12, goes outside the box. The dividend, which is the thing that's being divided, goes inside the box. Check. We did both of those things. Cool. So how many times does this divisor, right, so the 12, go into the first digit? And we're gonna go ahead and walk through this. And I know some of you would skip a step, right? 12 doesn't go into 5 at all, so it gets a 0. Now sometimes we don't write that 0, sometimes we just skip right to the 52, but it's 0. So most of the time we just totally skip this step, but really what you're doing is the 0 times the 12 would be a 0, and then you'd add straight down, right? So most of us just skip to the step where we're like, okay, cool, the first number this is going to go into is actually the 52. So how many times does 12 go into 52? Well, 12 goes into 52 4 times and gives me a 48, right? The way I got the 48 is by doing 4 times both the 10s digit and the 1s digit, and I get a 48, and then I subtract straight down. When I do that, I'm going to get that this is a 4, and then I'm going to drop the next digit down, and we're going to play the same game. How many times does 12 go into 43? Well, that's 3 times, and that would be 3 times the 12, right? So that's a 36, and then I subtract straight down, and then I get a 7, and I drop the 4 all the way down, and I get a 74, and the question is how many times does 12 go into 74? And the answer should be 6 times, because that's 72. And then I subtract straight down, and now I get a 2, and because I can't go any farther because I'm officially out of things, if you're not going to make a decimal value, and this was a 0, by the way, it kind of looks like a 2 the way I wrote it, that's my remainder, right? Now, I realize that if you were going to use a decimal, you could go farther, so what I end up getting is that this answer, right, so my answer is the quotient. So this thing right here is called the quotient, right? So the quotient plus the remainder over the divisor. Now, I realize that you could make that a 1/6, but that's the idea. Now, I understand that you're probably used to writing this more as a mixed number, right? You're more likely to write this as a 436 with a 1/6 right next to it, but for the purpose of our goal here, I want to point out that really the operation that's happening is a plus, right? So it's a quotient plus the remainder over the divisor. And yes, in this particular example, it could be simplified to a 1/6, but let's just keep moving forward. Okay, so we're now going to take that same skill that we just did with long division of numbers, and we're going to do long division of polynomials. Good times. All right, so let's do the same skill. Dividing polynomials is basically the same thing. So we have this sample problem. We're going to write things, the same thing with the division box. So I'm going to write the divisor, the x plus 2, outside the box, and I'm going to write the x squared plus 5x minus 3 inside the box. Okay, check. Did it, did it, did it. Okay. Now, we only really care about the first term in each of these standard form polynomials. And so think about it this way. It's sort of like you're driving the car and your kids are in the back seat. I get that you guys are the kids. So at this point, maybe it's like your mom's driving the car and you're stuck going to the grocery store because mom's going to the car, right? When I go to the store, if my son's with me, he's just stuck tagging along because he's 2 years old, and that is what it is, right? So it's only the driver that makes the decision about where you're going, right? So what I'm going to do is let's switch colors for a sec. All right, so my job is to pick, I want to figure out what I have to multiply this lead term by, right, the lead terms, to get this lead term. Well, the answer is to make an x look like an x squared, I would have to multiply by x. So I'm going to go ahead and do that, but just like I did on the previous slide, where when I multiplied by 4, I had to multiply the 4 by the entire number 12, which means by the 10s digit and the 1s digit. Well, the same thing's true here. I have to multiply that x by both. So I'm going to get x squared plus a 2x, and then just like I did on this slide where I subtract straight down, I'm going to have to subtract straight down, but because this is a binomial, I'm going to have to make it clear that that minus goes to both of those terms. So I'm going to get x squared minus x squared, which is gone. That's the whole point, and if you've watched division, that's usually what happens, right? It starts to move over towards the right as you move down, right? And I'm going to get a 5x minus this 2x. Well, that's going to be a 3x, and then I'm going to drop the next term down just like we did when we did the other division. So let's switch colors again. Okay. There we go. All right, so now I'm going to ask myself, what do I have to multiply this thing by to make it look like the lead term? Well, that would be a positive 3. So now I distribute that positive 3 to both of those terms, and I get a 3x plus a 6, and then I subtract straight down. Well, 3x minus 3x is gone, which is totally the whole point. Negative 3 minus a 6 would be a negative 9. And now that this degree is smaller than this degree, this is called my remainder. So my answer, right, my answer is going to be my quotient, which is the thing on top of the box, x plus 3, plus my remainder over my divisor. And that's how we do log division of polynomials. It's the same set of skills that we just did with numbers that you learned in 4th grade, but it's a little bit different because you've got x's. Same skill, just a little different. All right, let's go ahead and walk through some examples. So we're going to go ahead and divide this. So I'm going to do less of the color switching moving forward just because it takes an awful lot of time. So go ahead and write this out. So I'm going to have to ask myself, what do I multiply this x by to make it look like an x squared? And the answer is an x, and then I distribute the x to both of them. So I get x squared minus x, but then I subtract straight down. Well, x squared minus x squared is gone. Negative 7 minus a negative 1 would be negative 7 plus 1, so that's a negative 6x, and I drop the 1 straight down. What do I have to multiply this x by to get a negative 6x? Well, the answer is a negative 6, which then gets distributed to both of them. So negative 6x plus 6, and then I subtract straight down. Negative 6x minus a negative 6x is gone. That's the whole point. And then I get a 1 minus a 6, which would be a negative 5. This is my remainder because it's a lower degree than the original function, and my answer is x minus 6 plus the remainder over the divisor. All right, you go ahead and give one a try. You can pause me if you want. So I put my x plus 3 outside the house. I put my x squared plus 6x minus 4 inside the house. What do I have to multiply x by to get an x squared? Well, that's an x, which I then distribute to both of the terms. So x squared plus 3x and subtract straight down. X squared minus x squared is gone. 6x minus 3x is a 3x, and I drop the next digit down. To get an x to look like a 3x, I need to multiply by a plus 3, which then gets distributed to both terms, so that's 3x plus 9, and then I subtract straight down. 3x minus 3x is gone. Negative 4 minus a 9 is a negative 13. Since that's degree 0 and this is degree 1, this is my remainder. So my answer is x plus 3 plus my remainder over the divisor. All right. So let's talk for a second about placeholders. So the number 108 is not the same number as 18, right? This is because the 0 in the middle of the 108 is a placeholder saying that there are no 10s, right? The 10s are missing, so there's no 0 digit. Similarly, the number 640 is not the same as the number 64, right? There's a 0 at the end because it's saying there's no 1s. So here, the 4 represents 1s digits, but here we're being told there's no 1s digits and the 4 is 10s digits, right? So just to be clear, those zeros in numbers matter, right? So note that we don't generally put a placeholder at the front of a number. So like 18 is the same as 018, but we just don't bother to write the 0 in front of the 18. That's weird. So by the same token, when we perform division with polynomials, we need to write a placeholder if there's any power that's missing. So for instance, if you have x cubed plus x to the plus 8x rather minus 3, there's a missing term. There's no x squared, right? Usually between an x cubed and an x, there would be an x squared. So we'd write it as x cubed plus 0x squared plus 8x minus 3. Sometimes the placeholder is the constant, like if I gave you x cubed plus 5x squared plus 4x, there's no term missing on the front, but there is a term missing at the back because there's no term with a 0 power of x. So we would write it as x cubed plus 5x squared plus 4x plus 0. So the next several problems are going to walk through ones where we have placeholders, and it matters when you're performing long division. So far you haven't seen any that have that. All right, so we're going to do x cubed minus 5x squared plus 2, all divided by x plus 1. When I write this out, I need to make sure that I write a placeholder for anything that's missing. Well, what's missing here is that there's no linear term. There's no linear term, right? There's no 0, there's no just an x, so there's no linear x term, right? So we write 0 for that. And then we do the same scale that we've been doing, right? So I ask myself, what do I multiply x by to get an x cubed? The answer is x squared, and then I distribute that to both. So I get x cubed plus x squared, and then I subtract straight down. X cubed minus x cubed is gone. Negative 5x squared minus an x squared would be a negative 6x squared, and then I drop this 0x down. So I say, what do I have to multiply by this x by to get negative 6x squared? Well, that's a negative 6x, right? So negative 6x squared minus 6x, because remember, I'm distributing this to both of those two terms. And then I subtract straight down. Notice that this was a 0, not a 6. They just kind of look alike. Negative 6x squared minus a negative 6x squared is gone. That's the whole point. 0 minus a 6x would be a plus 6x, and then I drop this plus 2 all the way down. Last round, what do I have to do to this x to make it look like a 6x? Well, that's a plus 6. So when I distribute the 6, I'll get 6x plus 6 and subtract straight down. The 6x minus 6x is gone. 2 minus the 6 is a negative 4, and that's my remainder because, again, it's degree 0 and the divisor is degree 1. So my answer is going to be x squared minus 6x plus 6 plus my remainder over my divisor. And I know there's always somebody who says, hey, Hogan, couldn't I write this as minus this over this? And you could, but I'm going to argue that this is a bad idea. The reason I think it's a bad idea is eventually, sometimes your remainder is going to have two terms. And if you factor the negative out like this, if your numerator up here had two terms and you take a negative out, you have to make sure you factor a negative out of both terms, and a lot of us forget to do that. So this is by far the better answer, even though I know you can do this. It's right, but it's a bad idea. Okay. Go ahead and try P7. You are definitely welcome to pause me if you want to do it without me first. So I have my x minus 2, and then inside what I'm missing is this x squared, right? So there's no x squared term in here. So I have an x cubed plus no x squareds plus 3x minus 9, right? So what do I have to multiply x by to get x cubed? Well, that's an x squared. So there's my x cubed minus 2x squared, and then I'm going to subtract straight down. X cubed minus x cubed is gone. 0 minus a negative 2 would be plus a 2x squared, right? And then I drop this 3x down. What do I do to x to make it look like a 2x squared? Well, that's a plus 2x, right? So I'm going to get a 2x squared minus 4x, and then subtract straight down. So the 2x squared minus 2x squared is gone. I have a 3x plus a 4x, so that'll be a 7x, right? And then I drop the 9 straight down, right? And then lastly, I multiply by a plus 7, right? When I do that, I'm going to get 7x minus 14, and I subtract straight down. 7x minus 7x is gone. Negative 9 plus a 14 should give me a 5. That's my remainder. So my answer is x squared plus 2x plus 7 plus my remainder over the divisor. So one interesting note, because there's always somebody who says, hey, Hogan, it's fine, I don't need the placeholder, it's okay. Well, here's the problem. If you don't have the placeholder, notice that what happened right here, let me just switch colors for a sec. This was an x squared. So what happens? What happens if there's no placeholder? Okay, and essentially the answer is you end up trying to add terms that aren't like terms. So if we had tried the same thing without the placeholder, here's what goes wrong. Okay, you'd do the same first step. You'd multiply by an x squared, and you'd get x cubed rather, minus 2x squared. Well, look what happens. These are not like terms. They can't be combined. So do you have to actually put a 0 for the placeholder? No, you don't. So the idea behind the placeholder is that only like terms can be combined. So one way that other people will sometimes do it is instead of writing a 0 there, they'll just intentionally leave a space. So there's the x cubed, they leave a space for the x squared plus 3x minus 9, and that'll get you the same answer as this. Like that'll work the same way that this did. It's just, the idea is you have to recognize that you want your terms to line up, and that without that placeholder, they won't line up. So that placeholder can be a 0x squared, it could be an empty spot, so that when you write your next line here, you have the x cubed minus the 2x squared, but see, the 2x squared has to line up here, it can't line up here. That's the idea, okay? All right, so we're gonna go ahead and do, let's do an E8 and a P8, and I think then we move on to some synthetic division stuff. So this one's a little tricky, so for a couple reasons, right? So I have a cubed, a squared, a linear term, and a constant. There's no placeholder there, but there's a 0x missing from my divisor. So when I write this out, there's a 2x squared plus a 0x plus 1, right? That's a placeholder. And it's going into something that didn't need a placeholder. What makes this a little tricky is the placeholder, and then also that you're going to have multiple rounds here. This is going to be a fairly long long division problem, which is funny because it's called long division, so it checks out. All right, so what do I have to multiply the 2x squared by to get a 4x cubed? Well, that would be a 2x, right? So this is going to be a 4x cubed plus 0x squared plus a 2x, and then I subtract straight down, right? This is 0, right? The negative 2x squared minus a 0 is still just going to be a negative 2x squared, right? 6x minus 2x would be a plus 4x, and now I drop this down because notice what I'm multiplying by is a trinomial over here, so I need 3 terms. Back here, let's go to this one, I only needed 2 terms because this was a binomial, but now this divisor has 3 terms, which means I'm going to have 3 terms. So now what do I have to multiply the 2x squared by to get a negative 2x squared? Well, that's just a negative 1. So I get a negative 2x squared minus a 0x minus a 1, and then I subtract everybody straight down. So negative 2x squared minus a negative 2x squared is gone. 4x minus 0 is still a 4x. Negative 4 plus a 1 is a negative 3. And now this is my remainder. So I know there's still an x here, but notice that this is degree 1 and the divisor is degree 2. So I'm done, and that's my remainder. So my answer is 2x minus 1 plus the remainder over, and then I'd probably write the divisor without the placeholder. You don't have to, you can write it with it. So this is that case I was talking about where you see how you now have a remainder with 2 terms. And it's important with a remainder with 2 terms that you don't just factor out a negative and not pay attention to it affecting one or the other. So if I were to factor a negative out of this numerator, it would affect both the 4x and the 3. So just to be clear, you could make this a negative, right? Like instead of making it a plus, you could make this a minus, but then it would change the sign on both things on the top. So this would become a negative 4x plus 3. This would be an alternate version of the right answer. But again, I'm going to stand by the fact that that's a bad idea, right? This is a bad idea. It's not wrong, but if you factor out that negative, you're factoring out a negative out of everything on top, okay? All right, so let's go ahead and try one. So give P8 a try. Same situation, you're going to have a placeholder in your divisor. So notice that I have no x's in my divisor. I have an x squared and I have a constant, right? But I'm missing that x term. So 0x minus 3. My dividend is a negative 6x cubed plus 4x squared minus 2x minus 8. So what do I have to do to this to make it look like this? Well, that would be a negative 3x, right? So negative 6x cubed, sorry, my bad, plus 0x squared plus 9x, and then subtract straight down. So negative 6x cubed minus negative 6x cubed is gone. 4x squared minus 0x squared is still a 4x squared. This is a negative 2 minus a 9, so that's a negative 11x, and then I drop the negative 8 down. What do I have to multiply a 2x squared by to get a 4x squared? Well, that's a plus 2, so I'm going to get 4x squared plus 0x minus 6, and then subtract straight down. So I'm going to get a 0, I'm going to get a negative 11x, and I'm going to get a negative 8 plus a 6, which would be a negative 2, so this is my remainder. So I'm going to get that the answer is negative 3x plus 2 plus my remainder over my divisor. Now that answer is great, and it's the answer I would suggest. Oh, sorry, that's a minus 3. My bad. This is the answer I would suggest, right? It is also a correct answer, so this is okay, but a bad idea. It would also be an okay answer to factor out a negative from that remainder. If you did that, you'd get a minus here, and then it'd be a positive 11 and a positive 2. The reason I suggest that it's a bad idea is that most people forget to change the sign on the 2, okay? So it's not that it's wrong, it's just I'm trying to troubleshoot mistakes that people commonly make, and a pretty common mistake is that if you factor this negative out, you forget that the negative impacts both of the things on top of the fraction. All right. And that's it for this video.